this is Brittany, and this is my Module 4 presentation on solving equations. So one thing that was brought up in a couple of the lecture videos over the past couple of weeks was the idea that we don't need subtracting anymore. We're not subtracting anymore, instead we're adding a negative. Similar concept with dividing, that we're not dividing anymore, we can just use multiplication. I want to give a little bit of pushback on this because I think that it takes away from some of the algebraic reasoning that students can be doing. So for example, this problem was given in one of the lecture videos this week. X minus 2 equals 5. We could go through the process of adding 5 to both sides of this equation to solve for x, or we can kind of just ask our students, we can stop here and just ask our students, what number minus 5 equals 2? And that really uses their algebraic reasoning skills. And that's a lot easier. It's a lot easier to say, well, what number minus 5 equals 2 than saying, well, what number plus negative 5 equals 2? So hopefully that makes a little bit of sense in why I'm kind of giving a little bit of pushback against kind of getting rid of the whole idea of subtracting. So next, I want to address something that I brought up in my presentation last week, which was the idea of showing 0 pairs and showing 1 pairs. So I thought that maybe showing 0 pairs by drawing a 0 around something could just look like we're circling it and doesn't necessarily show that it no longer adds value. But I thought that we could actually draw the 0 with the dash through it. And that would be a better representation that it's canceling out, even though we don't use that anymore. So moving forward, I will be using the, I will show 0 pairs, which uses the the additive identity to show that positive and negative numbers create 0 pairs, 0 value, by drawing a 0 around it with a dash through it. And for my 1 pairs, I will just be drawing a giant 1 through any 1 pairs, which use the multiplicative identity. So this is the problem that we were presented with this week. The first step that I will take mathematically is I want to rearrange the left-hand side of this equation using the commutative property of addition, which says that I can rearrange these terms because 2 plus 4 and 4 plus 2 both equal the same thing. So instead of negative 34 plus 1/2 x, I will have 1/2 x minus 34 on the left-hand side, and my right-hand side will stay the same. The reason that I'm doing that is just to get rid of this negative 34. I want to work with as many positive numbers as possible. That is just a preference of mine. So the next thing that I need to do is I need to get rid of this minus 34. I'm going to do that by using my additive identity. So I'm going to create a 0 pair on the left-hand side of my equation, and anything that I do to the left-hand side of my equation, I have to do to the right-hand side of my equation in order to keep it balanced. So anything I do to the left-hand side, I have to do the same thing to the right-hand side. And to the left-hand side, I'm going to add 34 in order to create this 0 pair here, and I will denote that by drawing my giant 0 around it. And now on the left-hand side, I am just left with 58, so negative 58, sorry. So we have 1/2 x on the left-hand side is equal to negative 58. The next thing that I'm going to do is I know that 58, I'm going to do a little scrap work over here on the left. 58 is equal to negative 28 minus 34, or plus negative 34, right? I know this to be true, so I can replace this 58 with my equation, or my expression, negative 28 minus 34. So I'm going to go ahead and do that. I'm going to erase this negative 58, and instead I'm going to write, I'm sorry, I forgot to bring down the plus 34, but I'll do that in this step. So this will be negative 28 minus 34, and then plus 34, which we brought down. So again, I did that so I could create this 0 pair here. Negative 34 plus 34 creates a 0 pair, and that portion of our equation no longer holds any value because of our additive identity. So next step, we have 1/2 x is equal to just negative 28. So at this point, this is where I'm saying that we could just stop here and ask our students, well, 1/2 of what number equals negative 28, or what number divided by 2 equals negative 28. But for the purposes of this video, I will continue on. So we also know something else that we should know at this point is that we can rewrite any whole number as itself over 1. So we can rewrite x as x over 1. So I'm going to go ahead and do that, times x over 1. We also know that when we multiply fractions, we are multiplying our numerators and denominators straight across. So now in my new numerator, I have x1 times 1, x is x, and 2 times 1 is 2. And that still is set equal to negative 28, which we can still, using the same concept, as rewrite as negative 28 over 1. So now we have our number x, our unknown, divided by 2. In order to undo that, we need to multiply by 2. We need to do the inverse of dividing by 2, which is multiplying by 2. So I'm going to take that, I'm going to multiply by 2 on both sides of my equation to make sure that it's balanced. I'm going to go ahead and rewrite, using that same concept, each of these 2's as 2 over 1, 2 over 1, and then just multiply my numerators and denominators straight across. So on the left-hand side, we are left with x times 2, or 2 times x. And in our denominator, we have 2 times 1. And that is equal to negative 28 times 2 all over 1. And what I created just now is I've created a 1 pair using the multiplicative identity. So now on our left-hand side, we are left with just x, or x over 1, which we know is just x. And on our right-hand side, we have negative 28 times 2, which is negative 56 over 1, which is just negative 56. So we have successfully solved our equation for our variable. X is equal to negative 58. I'm sorry, negative 56.